I saw a question the other day about setting a datum plane tangent to a rounded corner of a pad. I'm sure more have that question, so I decided to answer it in the form of a video. I'll just do a quick sketch and pad it to 10 millimeters. I'll put a fillet of 10 millimeters on one corner. As you can see, if you just add the datum plane and attach it by selecting the corner, you actually get attachment mode inertia 2-3 and tangent is not on offer. The plane is oriented as you wanted, but it's inside the corner. Usually that's good enough. You can put a sketch on that plane and use a bit of Z offset to perform whatever operation you wanted. For example, I put a circle on the plane, close the sketch, and then adjust Z until the circle is fully exposed. Now I can pocket that through all. The problem is it's not fully parametric. If I change the size of the pad, my hole starts inside the pad and even the direction gets reversed. I can correct this, but it requires several adjustments. So what about actually placing the datum plane on the arc? It would make the model more robust at least. Going back to the model, I'll place a new sketch on top of the pad. Using the external geometry tool, I'll bring in the arc describing the corner. Now place a line from the center of the arc and end it on the arc itself. Note that I have auto constraints turned on in the edit controls. Now put a point on that line. Make the point symmetrical to the two endpoints of the arc. Now the new line perfectly bisects the arc. Now I'll place a new line outside of the arc very roughly at a right angle to the bisection. Constrain the endpoint of the bisection to be on the line, and now explicitly constrain the second line to be at right angles to the first and close the sketch. Now I can create the datum plane. In the attachment dialog, select the second line as the primary reference. Now I'll add the bisection line as the secondary reference. Finally, set the attachment mode to normal to 3 points. We're still not quite there. The datum plane's origin is on top of the pad, and we want it centered in the Z direction. Go to the Sketches data pane and set the attachment position.z to -pad.length divided by 2. By setting it as a formula, you make the design more parametric since it will recompute if you change the height of the pad. Because of the way the external reference is set, you can also change the size of the pad without any issues. Of course, if you change the shape of the pad, the topological naming problem might bite you. The key to this is remembering that a sketch doesn't have to be a shape that you will then pad, pocket, or revolve. It could be a scaffold to help you place other things. One final thought. Having said all of that, this may not be what you wanted. If your pad is square, all is well. But if it's rectangular and you are hoping to pocket a hole all the way through like I did and come out the other corner, it's not going to happen. The pocket also won't pass through the center of the rectangle. The problem is the arc on the corner is bisected, effectively giving us a 45-degree angle across the rectangle. But the diagonal of a rectangle is not 45 degrees, it's just two angles that add up to 90 degrees. But if that's what you were hoping for, all is not lost. Let's look at the sketch again. You can kind of see the problem here. We are not passing through the center of the rectangle, but there's no reason we can't. We just need to make a few changes. I'm going to get rid of this point that makes our line bisect the arc, and we'll get rid of the coincidence constraint that fixes it to the center of the arc. Now we can move it freely. I'm going to fix it to the center of our rectangle. Now the trick to this is that as long as the line passes through the center of the arc, it will be normal to the arc, and so a line at right angles to it will be tangent to the arc, just not centered. Let's close the sketch and have a look at what's happened now. As you can see, we are not exactly at the corner, but then we couldn't really expect to be. The reason is we insisted on passing exactly through the center of the rectangle, and so the position we came out is mirrored to the position we entered. If we really want to come out at exactly the corner, that too is possible. I'll go back into the sketch again. Remove the coincident constraint on the origin point. I'll bring in some external geometry to get us the corner we want to come out of and make the endpoint coincident. Again, because we're passing through the center of the arc, we remain tangent to the arc. I'll close the sketch again and look at how we did. Dead on. So while this technique is a much bigger pain than simply highlighting the corner and popping in a datum plane, then adding a dash of Z offset, it does give us much greater control over exactly how we pocket the pad. Thank you for watching. If you liked this video or found it useful, please like, subscribe, and share. If there's anything you'd like to see covered here, please let me know in the comments below.